Hierarchical clustering is an unsupervised machine learning algorithm. It is used to group unlabeled data into a hierarchy of clusters based on similarity or distance, rather than predicting target labels, making it an unsupervised technique for pattern discovery. Let's understand the concept of hierarchical clustering using a college example, with total strength of 1,000 students. We call it as a single cluster named as C. The single cluster C is divided into 5 branches as civil, computer science, electronics and communication, electrical and mechanical engineering. Let's call these clusters as C1, C2, C3, C4, and C5 respectively. Please note that each cluster has equal strength of 200. However, the clusters can have different strengths also. So, now we have 5 clusters at this stage. Now say, the 5 clusters are further divided into 4 clusters of strength 50 each. Again, note here that the clusters may be of different strengths also. Name these clusters as Y1, Y2, Y3, Y4 for each branch. Therefore, now, we have 20 clusters in total. Further, each H cluster is divided into 2 sections A and B. This makes a total cluster strength of 40 now. It can be noted here that, we started with a single cluster C. Then, in the next stage, there are 5 clusters C1, C2, C3, C4, and C5. Further, we have 20 clusters in next stage, and, finally 40 clusters in last stage. This is called as top-down approach or divisive clustering, where, we started with a single cluster C, then, further divided into 5 clusters, and, further divided into 20 clusters, and, finally into 40 clusters. Same way, if we start with 40 clusters, so as called the bottom-up approach, or agglomerative clustering, then, further clustered into 20 clusters, and from 20 to 5 clusters, and finally, the single cluster. This is bottom-up approach. Let's have few examples of hierarchical clustering. Very firstly, the Google map. When we zoom in or zoom out, the buildings or nearby areas appear closer or farther. Secondly, the binocular vision. This is as same as Google map. When we focus the binocular, we tend to get closer view of the scene, and vice versa. Thirdly, the customer segmentation with respect to particular segment. And lastly, the news organizing in respective categories. Some key points about hierarchical clustering. It's the unsupervised machine learning model. Similar data points are grouped into hierarchy of clusters. The cluster's distance is called as linkage, and it decides the number of clusters. Hierarchical clustering can be implemented using either top-down or bottom-up approach. Both approaches result in same clustering results. A hierarchical clustering is summarized using the tree-like structure. This is called as dendrogram. Now, let us take a numerical example of hierarchical clustering to understand the concept. To understand the concept, take the 5 students' marks as shown here in the table. It has students' ID along with their marks. Now, as part of step 1, assign each student as an individual clusters with unique cluster ID as 1, 2, 3, 4, and 5. It can be sensed out here that we are following the bottom-up approach, and the target is to reach the single unified cluster. In step 2, compute the intercluster distances. That means, compute the distance of each cluster with each one. As, it can be seen here, that the distance of a cluster with itself is 0. That means cluster 1 to cluster 1 distance is 0. Now cluster 1 to cluster 2 distance by taking simply the difference of marks. Please mind to take only the magnitude of distance. That means, ignore the sign of the distance. Only positive distance values. Similarly, cluster 1 to cluster 3 distance. Cluster 1 to cluster 4 distance, and finally, cluster 1 to cluster 5 distance. Same way, distance of cluster 2 with all clusters. Again, take only the magnitude of distance. That is, by ignoring the distance sign. Again, distance of cluster 3 with all other clusters. Distance of cluster 4 with all others. And, finally, distance of cluster 5 with all clusters. It is clearly observed that distance of a cluster with itself is always 0 and marked with blue color. Now from the table, it can be observed that 3 is the minimum distance after the self distance, marked as red color, and this distance 3 is the distance between cluster ID 1 and 2. At this point, this 3 is the linkage value. And, cluster 1 and 2 can be grouped together as shown. The clusters 1 and 2 are grouped together and marked as green color. The linkage is also put on the dendrogram below representing the cluster 1 and 2 clubbed together. Therefore, the dendrogram starts building up now. Now, in step 3, the club data points 1 and 2 are put together in the table and put with the higher value as 10. Now 1 and 2 are under a single cluster. Cluster 1 to cluster 4 distance. Same way cluster 1 2 to cluster 3, then cluster 1 2 to cluster 4. And, finally, cluster 1 2 to cluster 5. Same way, cluster 3 to all other clusters, then cluster 4 to all clusters. And, finally cluster 5 to all clusters. Again, as seen earlier, it is clearly observed that distance of a cluster with itself is always 0 and marked with blue color. Now from the table, it can be observed that 7 is the minimum distance after the self distance, marked as red color. 7 is the distance between cluster 3 and 5. This is next linkage and plotted on dendrogram below. Hence, cluster 3 and 5 can be clubbed together under one cluster marked as blue over here. The clusters 3 and 5 are grouped together and marked as blue color. The linkage is also put on the dendrogram below representing the cluster 3 and 5 clubbed together along with 1 and 2. In the table also, 3 and 5 are clubbed together same as that of 1 and 2. Now, compute the intercluster distance as done earlier. Cluster 1 2 with all clusters as shown in table, then cluster 3 5 with all clusters, and finally, cluster 4 with all ones. Again, as seen earlier, it is clearly observed that distance of a cluster with itself is always 0 and marked with blue color. Now from the table, it can be observed that 10 is the minimum distance after the self distance, marked as red color. Hence, cluster 1 2 and 4 can be clubbed together under one cluster. The dendrogram is also updated with new cluster formation. The cluster 1 2 and 4 are marked with green color here. And the table is also updated with 1 2 and 4 in one cluster and 3 and 5 in other cluster. Now, compute the intercluster distance as done earlier. Cluster 1 2 4 with clusters 3 5 in table. And same way, cluster 3 5 with all others. Again, as seen earlier, it is clearly observed that distance of a cluster with itself is always 0 and marked with blue color. Now from the table, it can be observed that 15 is the minimum distance after the self distance, marked as red color. Therefore, the cluster 1 2 4 can be clubbed with cluster 3 and 5. The dendrogram is also updated with new cluster formation. That means, all points are in a single cluster now, and here is the final dendrogram. Let's note down some points about the dendrogram. Dendrogram is a visual representation of cluster relationship with respect to linkage as one of the metric. Clusters merging can be observed step by step at different linkages. Dendrogram is mostly used in cluster relationship visualization in machine learning domain. It's quiz time now. To submit your quiz response, please click on the Google form as marked below in the comment section. Type your response option against each question followed by comma and submit. All are multiple choice questions. Only one option is correct for any of the question. Select the proper option and put down in the Google form field. After submission of Google form, you should get the score analysis in few hours from Academy. Wish you a very good luck.